c squared. I know A1 is gamma, so that's c squared plus gamma squared v squared over c squared, which is 1 plus gamma squared v squared over c squared. That's what we had before. A1 we knew was gamma, so that's good. Divided by c squared, fine. All right, so I've got 1 plus 1 over 1 minus beta squared. That's just gamma squared. Times v squared over c squared, which is just beta squared. So 1 plus beta squared over 1 minus beta squared. And they've got a common denominator. So that's 1 minus beta squared plus beta squared over 1 minus beta squared, which is 1 over 1 minus beta squared, which is just gamma squared. Gamma shows up yet again. So B2 is equal to plus or minus gamma. If the speed is 0, gamma equals 1. If I look at our relationship that we had before, that the time in the prime frame is equal to b1 times x plus b2 times t. Then at x is equal to 0, so let's just assume that s prime and s are right on top of each other. Well, the time would be the same for both. If S prime is traveling at no speed whatsoever, it has the exact same change in time as S does. So if they're parked right on top of each other, so at x is equal to 0, t prime equals t, given speed is 0. In other words, it's got to be positive. B2 has to be positive gamma, so therefore B2 is equal to gamma, positive gamma. All right. So we now have, we're just one more to go. From what we had earlier, I know B1 times B2 is equal to, well, actually, let me jump back here. From here, this equation right here. B1, B2 is going to be A1 squared V over C squared.
And let me just double check that didn't screw up a square somewhere.
So A1 squared V equals negative C squared V1 V2. A1 squared V equals negative C V1 V2. So B1 B2 equals a negative A1 squared V over C squared. I know B2 is gamma, so I have B1 therefore equals negative A1 squared V over gamma C squared. A1 we established was gamma already. I could have made that substitution there, but didn't. V is a positive number. C is a positive number. So this is a positive number here. B1 is either plus or minus. Well, if what I've circled here is positive and I got a negative in front of it, B1's got to be the negative. Negative V is V over C squared times gamma. So I now have the second relationship. T prime is equal to gamma T minus V over C squared X. Factoring the gamma out. So if I have a primed frame, if I have a frame moving away from me, that's the relationship. In the positive X direction. Likewise, we flipped it around and looked at it from the point of view of if S prime with the still frame and S was moving in the negative X direction, hopefully you can see it well enough that we can come up with another center here where X is equal to gamma X prime plus VT prime, and T is equal to gamma T prime plus V over C squared times X. That's an X. Now, if in doubt whether it should be plus or minus, do the Galilean relativity thing. Like we did with the car, the person standing on the side of the road. Whatever sign shows up there is going to show up here. These are known as the Lorentz transformations. This is all part of Lorentz trying to explain why there was no velocity or speed of the observer and what Maxwell had done. Just Lorentz could not bring himself to make that leap that Einstein did, that the speed of light was constant, regardless of the reference frame. All right, questions to here? So now it is time to revisit large thing into small thing. As soon as I can find it, there we go. In this scenario, I have a person carrying a long pole. 16-meter long pole. He is going to try to fit it into a 10-meter long barn. The 16-meter and 10-meter are the rest lengths, or proper lengths. So if I had the pole sitting right in front of me and I measured the length, so it'd be 16 meters. If I had the barn right there and I pulled out my measuring tape measure, to come out to 10 meters. I'm going to describe 3 events. Event number 1. Left end of pole is in the garage, or barn, I guess, barn. When that happens, when the left end of the pole gets inside here, the left door and the right door both close. So left door closes. Event number 2, the right door closes. And event number 3, right end of pole smashes into the right door.
So there's, like, by left and right, you mean a door on each end of the?
Yeah, barn's got the door on each end. So as soon as the left end of the pole is inside the barn, just picture 2 doors instantaneously go. Like in Star Wars: A New Hope, when they're on the Luke and R2-D2 are on the Death Star, except faster. All right, so let's take a look at it from 2 different points of view. So let's take it first from the barn's point of view. So event 1 happens, well, we're going to establish this is x is equal to 0. And this will be x prime equals 0. We will synchronize our time so that when the left door closes, that's time is equal to 0 for both frames. So anyway, from the barn's point of view, event 1 happens at a position of 0 meters and 0 nanoseconds. The right door closes at a position of 10 meters and 0 nanoseconds. Because from the barn's point of view, both the doors are going to close at the exact same time. And the right end of the pole is going to smash into it at, well, we need to figure that out. I need to give you a speed of it. Let's come up with a beta is equal to 0.866. Just to make life more convenient. So if beta is 0.866, what is gamma? Close enough to 2. So beta 0.866 corresponds to gamma equal to 2. If you want to do 1.999, 3 nines?
Yeah.
3 nines? Go for it. But I'm going to do 2. How long is the pole? From the barn's point of view, how long is the pole? If gamma is 2, how long is the pole? Think length contraction.
32 meters.
Other way.
8
Oh.
meters?
8 meters. The proper length is equal to gamma times the length in the reference frame. And so this is 16 is equal to 2L. L would be 8 meters. And so if I've got my 10 foot or 10 meter long barn here, and the pole, the left end has just cleared, the pole is 8 meters long, this is 10 meters long. So from the barn's point of view, there's another 2 meters to go. Traveling at a speed of 0.866, then we need to figure out how much time it would take for the pole to, the right end of the pole to smack into the right door. And so the time is going to be the distance divided by 0.866 times 3 times 10 to the 8th meters per second. And what do we get for the time?
.698.
So 7.698 nanoseconds. So from the Barnes point of view, the event 3 happens at a position of 10 meters and a time of 7.698 nanoseconds. So left end enters, both doors close simultaneously at time is equal to 0 because we're synchronized when the left end enters the barn. And the pole smashes into the right end at 7.698 nanoseconds. All right, we can now just do a little plug and chug. Now, from the pole's point of view, I lost. So X prime is going to be for event 1. X prime is equal to gamma times X minus V, which is 0.866C, times time of 0. So we get X is equal to 0 meters. T prime, we should also get 0 meters because that's when they synchronize the clocks, but let's do it anyway. So that's 2 times the time 0 minus V over C squared times the position in the X frame, and we get 0 seconds, or nanoseconds. So if we do the pole's point of view, event 1 happens at 0 meters, 0 nanoseconds. Because, well, we define the left end of the pole to be the reference point for the pole, left end of the barn, the reference point for the barn, and we synchronize the clocks at that moment. So, no surprise. Next step. The left end, the right door closing. So, event 2. X prime is equal to 2 times X, which is 10, minus V times time of 0. $20 meters. Wait, did I do that right? Yeah, 20 meters. Okay. Sorry. T prime is equal to 2, I'm just plugging and chugging. T is equal to 0 minus V over C squared, so that's 0.866C over C squared times the position of 10. So that's 2 times 0.866. Actually, let's go ahead and multiply times 10. 8.66 over 3 times 10 to the 8th. Negative.
.773.
Say it again.
5.773 times 10 to the negative 8.
Or negative 57.3 nanoseconds. So from the Barnes point of view, from the pole's point of view, the right door closes at 20 meters, and negative 57.3 nanoseconds. And now we've hit 3. Even at 3. We have x prime is equal to 2 times x, which is 10, minus vt, so it's 0.866, times 3 times 10 to the 8th, times time, and that time for the third event is 7.698 times 10 to the negative 9th seconds.
I got 16.000.
So 16 meters. And which makes sense from the pole's point of view. The pole's hitting the right door, and so the distance to the door, the position of the door at that moment should be the length of the pole. And then t prime is equal to 2 times my time, which is 7.698 times 10 to the negative 9th, minus my speed, 0.866 c over c squared times my position of 10. So we're on negative 43.
Yeah, negative 4.234 times the
Negative
8.
4.23?
Yes, times 10 to the negative 8.
Oh, okay. 4.23 times 10 to the negative 8, or negative 42.3